Sec 1, Chapter 6, Angles and Parallels, Part 1. Now, in this part of today's chapter, we'll be looking at what are the different type of the angles, namely what is complementary angle, a supplementary angle, and an adjacent angle. Okay, and we can after that use the knowledge of these angles in order to find the value of the unknown angles. So we shall begin with our lesson for today. Question number 1, describe a point. Now, what is a point? A point actually itself marks a particular position in a plane. So a point itself has only position, it has no particular size. And points itself can form a line or even a line segment. Now, what is the difference between a line and a line segment? A line can be a straight line, a continuous straight line, or a curved line. Okay, but then for a line segment is a straight line in between two given points. So in this case, you can see as on a line itself, there is infinite number of points. You can have many points that lies on the line itself. So you can have continuously many points on the line, straight line, or the curve. So they are all little points. But itself, from the line segment, because it's a straight line between only 2 points, so it only has a fixed particular length. It does not continue forever. If that's the case, then what is a ray? A line segment is a line, part of a line between 2 points, but a ray itself is part of a line with only one endpoint. So for one endpoint, you can draw one straight line, and then it will continue with an arrowhead to show that the line can be extended in that direction indefinitely. Next, what is a plane? A plane has a flat surface, so a plane can come in terms of, for example, a horizontal flat plane. Usually we try to denote it by drawing a rectangle. Okay, and then you can have points, many different points that lies on the same surface plane. It can be a horizontal plane, or it can also come in the form of a vertical plane. Okay, or then you have many points on it, or you can also have a slanted plane that you cut through a figure or whichever. So a plane is just a flat surface. Okay, and in this case, a plane has no thickness. So from this, we know that a point itself can form up to make a line segment, a ray, or it can just simply lie on a plane. So a point itself has only a particular position, but it has no size. Up next, are you able to identify the following types of angles? Now, the first one has already been done for you. So we actually have an acute angle over here. This is called an acute angle. Why is that acute angle? Because it's an angle that is less than 90 degrees. So any angle that is less than 90 degrees is called an acute angle. Then what about the second one? This will be a right angle. Why is it called a right angle? Because the angle PQR over here is equals to 90 degrees. So every right angle is 90 degrees. Next, angle ZOY over here is more than 90, but is less than 180. So this is actually called an obtuse angle. Why? Because angle ZOY is between 90 degrees and 180 degrees. Next one, you can see with this angle over here is slightly bigger than an obtuse angle already, and it's very flexible. It can bend all the way back. So this is actually called a reflex angle. Okay, the Chinese answer like very flexible, bend backwards. So why is this called a reflex angle? Because the reflex angle STU, I should add a word reflex to it, is between 180 and 360 degrees before it becomes meet back to 1 point. Okay, then next one, last but not least, angle COD itself is a straight angle. What do you mean by a straight angle? Well, because they form a straight line. So the angles on the straight line itself here is 180 degrees. So angle COD is 180 degrees. Have you gotten your answer? Next one, we shall teach you how to use the protractor to draw the following angles. The first one now, in order to draw the following angles, I should always assume that, for example, I should start from 0 degrees over here. And I'll draw a straight line and mark a point. Then now I shall use a protractor. So now I'm going to measure protractor and I'm going to use this angle here. Mark the point, right? And then it falls, make it adjusted such that it falls on the straight line where 0. So where this corner here, or this corner over here is 0. So this is from 0. Then now from 0, I'll read all the way until 40, which is down here. And then I'll try to make a particular marking, 40 degrees. So 40 degrees is somewhere over here. Okay, then now I make my, I'll keep my protractor first. Then now I will match the marking to my point at the center and draw a line to join that up. Okay, and this will be the angle. And I will have this angle over here to be 40 degrees. Similarly, how do we draw an obtuse angle of 142 degrees? So I shall draw a straight line. So we will know that this one over here will be 0 degrees and this will be the center. Now we're going to call our protractor again. Okay, and then we are going to place the center, the 0 over here and the straight line. So make sure that you have 0, the dot here, and then this is the straight line with the angle from 0. And now we're going to read from here 0 all the way to 142, somewhere over here. Now notice that there is 2 rows of numbers. If I were to follow this number, that means I'll start from 0 over at this side. But since I'm drawing from here, so 0 will be the one reading from the outer number. So from here, 0 all the way to 142, so it'll be somewhere over here. So let me make a marking, 142. Okay, then I'm going to make my protractor disappear. Then making use of a ruler, I'm going to join the marking to the center of the point over here, as you can see. And I'll draw a line to connect the angles. So doesn't need to exceed too much. So this will be my line. 142 degrees. Next, I'm going to draw 240 degrees. But we notice that 240 degrees, this is actually a reflex angle. Okay, as usual, I'm still going to draw starting from a particular point and line first. Okay, so I should have a dot over here and the center. But now how am I going to draw 240? I do not have 240 degrees. So what can I do? I know I have a maximum of 180 degrees. So from 0 all the way to here is 180. So how many more else must I do to draw for 240? So what I'm going to do, I'm going to move my protractor to the other side. That means it will continue from 180 degrees all the way to the angle below. Okay, then I'm going to put it, let me shift it a little bit down here. So 240 is made up of 240 minus 180 is made up of 180 degrees plus another 60 degrees. So now you notice that my angle from 0 all the way to 180, and from 180 I'm going to continue with another 60 degrees. We're going to read the number outside. So 1, 2, 3, 4, 5, 60 degrees. So this number will be somewhere down here. Then now I shall use the ruler to draw and then make a marking over here. And we will have this full angle over here to be 240 degrees. Or that I can erase it a little bit to make the line inside the diagram. So this will be 240 degrees. Last but not least, now how do we draw 340 degrees? This is way beyond, right? much more than 180 degrees. Now we also know that 360 degrees is actually one full circle. So if it's 360 degrees is one full circle, so I'm going to move in this direction over here. So from 0 degrees, it will go from 0 all the way to probably somewhere that's very near to 360. So how far is 340 from 360? Well, it is actually just only 20 degrees away. So instead of using our protractor to draw, measure 360 degrees, 340 degrees, what I can do is I'm going to turn this around and I'm going to measure a 20 degrees instead, right? So the angle will actually travel from 0 degrees all the way to 360. So in this case, I'm just short of 20 degrees. So I just don't want the 20 degrees, right? From here, I can see that 20 degrees over here in this case. So I shall make a marking for 20 degrees. Okay, then now I'm going to keep my protractor. And then I'll call upon my ruler, use my ruler to draw the line. Join them together, and I shall draw a straight line to join that point to this center, and this will be 340 degrees. Okay, have you gotten the answer? So now we have completed drawing of angles using our protractor. Next, let's fill up some of the blanks for this part of the notes. Now, if the sum of two angles is 90 degrees, then these two angles are called complementary angles. Now, what does that mean? So, in a 90-degree right angle, I have two portions. One is angle A and angle B. They add up to 90 degrees. Next, if the sum of two angles is 180, then the two angles are called supplementary angles. What does this mean? Supplementary angles means on one straight line, if let's say I have a line over here, this angle A and this angle B, they add up to 180 degrees. So this is for supplementary angles. So this is number one, this is number two. Okay, now if two angles share a common side and a common vertex but they do not overlap, then the two angles are called adjacent angles. Now you can see it from figure number 2 over here. These two angles, angle A and angle B, they share one common side and they have a common vertex, a common point, but then they do not overlap each other. So these two angles are actually adjacent angles. They lie side by side each other. So next, so if you understand these few terms already, now let's find the complementary angle for 20 degrees. So what plus 20 degrees will give you complementary? Complementary means 90. So 20 plus what will give you 90? Well, the answer is 70 degrees. What about this 44 degrees? What plus 44 degrees will give you a 90 degree? So 90 minus 44, that will give you 46 degrees. Supplementary angle adds up to 180 degrees. So 170 plus what will give you 180? 10. And 105 plus what will give you 180? 75 degrees. So we shall continue with the next part. Number 5, from the diagram below, identify a pair of complementary, supplementary, and adjacent angles. So from here you can see diagram A. This is obviously the complementary angles. And then this one, diagram B, here adds up to 180. So this is quite obvious. This is supplementary angles. Okay, and diagram C, we have quite a number of different angles. Not very sure what they want. So let's try to fill in our blanks. Part A. From diagram A, a pair of complementary angles are angle AOC. So we read it as from one point to the angle. So the angle O C. So this angle O is in between from the point A and point C. So this is called AOC. So the angle that we want is always labeled in the middle, right? And the next angle this angle will be COB. So this is the angle O that we want. So this is angle COB. Right, from diagram B, we have a pair of supplementary angles that will be quite easily seen, YOX and XOZ. Right? Then from diagram C, a pair of adjacent angles on a line. So adjacent angles means they are side by side each other. They share a common side and a common vertex. Now you can see all the angles here actually lies on one common vertex over here. And we have quite a couple of different lines. So we can have the first pair, for example, QOR. This angle will be side by side, ROS. So that will be our first angle, then QOR and ROS. Then we can also have another pair if I can have ROS with SOP. And I can of course have SOP with POQ. And finally, I can also have this pair of angle over here, POQ with QOR. Have you gotten the answer? Okay, now we have learned quite a bit of theorems or different type of angle properties, and sometimes we will need to use them to state the reasons when we do our working to find the unknown values. So now here are some of the common properties of angles that we will use, and its abbreviation. Okay, now firstly, we have a sum of adjacent angles on a straight line is 180. You probably have learned that before. So this is given by the short form adjacent angles on a straight line. Adjacent angles, so ADJ, angles on a straight line. That means they add up to 180 degrees, or we can just write angles on a straight line. So this triangle A, B, and B plus C will give you 180 degrees. Then the next one is sum of all angles at one particular point. So you have particular point, and these are all the angles that add up together. So this is actually called angles at a point. Short form. And now we can see that A plus B plus angle C will give you 360 degrees. Next, we call this, personally I call this the letter X. Right, so it looks like a letter X anyway. So whereby the vertically opposite angles, the angles that are vertically opposite each other are equal, are a pair of equal angles. So X is equals to Y and A is equals to B. So how do we write this down in the short form? Vertically opposite angles, VERT, opposite angles. Alright, so I know A is equals to B and X is equals to Y. Have you gotten the theorems? Now we already know all these basic theorems, and how do we use these theorems to find the unknown angles? And along with it, we should write reasons for our working. So first, question 7a, you notice that all these angles here lies on one straight line. So you have y plus y will give you 2y, and at 80 degrees that will give you 180 adjacent angles on a straight line. So first I'm going to write down the property 2y plus 80 degrees to be equals to 180. Now this is given by the reason adjacent angles on straight line. So in actual part of the working, when we write it, we'll write it always with a bracket for the reasons. But the actual way we should write, you should visualize it probably to look something like you have, for example, in pencil, something that looks like equation or a line statement. And then after this, you have two columns. Okay, but you don't really need to draw them in your diagram or when you write them in your working. So this is just like something that goes along with your angles. Then this is your property name or the reasons. Okay, so for you to take note. Now we know 2y plus 80 equals to 180, so we will continue our working. 2y is 180 minus 80, that will give you 100, and y will be 50 degrees. So when I do my working, there's no units, but my final answer, then I'll write my units. Y equals to 50 degrees. Okay, and I'm going to extend that into next part. So we have part B. All this tree over here forms again 180 degrees. So we're going to write down our equation. To form an equation, a property in this case, so I will have 65 plus x plus 73. This is equals to 180. Again, I'm going to write my reasons. That is because of adjacent angles on straight line. Okay, with a bracket. And then now I'll go into finding out the working for the value for x. So x will be 180 minus 65 minus 73, and x equals to 42 degrees. So in my working, I don't write my units. My final answer, then I put my units. So you can see the structure. You can imagine that there's an invisible line over here. This side you write down your angles or the equation that form, and this side over here you write down the reasons for that statement itself in brackets. Let's finish up the last two questions. You can see over here that I have all these angles are angles at a point. They'll form 360 degrees, but I noticed that this angle over here is missing. But well, I have a vertically opposite angle over here, so we can see that there is a pair of vertically opposite angles. So this angle here and this angle here will be equal. So I can see that this angle over here is 3x. That's my very first observation. So I'm going to indicate that, okay, using a vertically opposite angles. And then not only just that, I noticed that I have this 7x minus 20, and this is y over here. They are also have a relationship. They are also a pair of vertically opposite angles. So now what can I do? What am I going to use to find the answers? I have two unknowns. I can't find both the unknowns directly at the same time. So probably what I can do is I'm going to use all the x together first. So I know that this two angle here, 7x minus 20 plus 3x will add up to, this is adjacent angles on a straight line. So I'm going to use that first to find the value for x. So I will have 7x minus 20 plus 3x to be equals to 180. This is because of adjacent angles on straight line. Then now I'll proceed to find x. 7x plus 3x, 10x minus 20 is 180. 10x is equals to 180 plus 20. 180 plus 20, that will give you 200. So x will be equals to 20 degrees. So x is equals to 20 degrees. So I already know what is x. How am I going to find what is the value for y? So I know quite clearly y is equals to 7 times x minus 20. So I'll put 7 times 20 inside. And what's the reason why I know that y is equals to 7x minus 20? The reason is because it's vertically opposite angles. Okay, and now using my calculation, 7 times 20 minus 20, that will give you 120 degrees. Answer. Okay, now let's do the last question. How do I find angle A? Well, this is quite simple and straightforward. Everything add up to 360 degrees. So that will be angles at a point. So that will be A plus 125, 52, 89 is equals to 360. This is called angles at a point. and then A will be equals to 360, subtract away all the other values, so A will be 94 degrees. Have you gotten the answer? Now we have come to the end of this part for today's lesson, so bear in mind and remember to fill up the cover page of your notes. See you for the next lesson.